Michael Shermer, the science historian, he once mentioned that Stephen Wolfram had approached him. Wolfram is working on his own theory of everything. He calls it a new kind of science and some powerful ideas about cellular automata and computation. And what Wolfram wanted to know was, how do you start a scientific movement? And Shermer's response was, most of the time they're never top down. They're always bottom up. So you have to get grad students, researchers, professors so passionate about the idea. It has to be so seductive, so attractive that they start espousing it. Why did string theory become so popular that it launched two superstring revolutions as well, despite making no predictions, despite the lack of falsifiability? If this was going to be a case study that'll be studied in the future, as a movement on a psychological level, why did it become so popular?
Well, I think there are two things. I mean, one is that, I mean, the fundamental problem the whole field has had since 1973 is that the standard model is too good. It's just that, literally every experiment anyone can do looks exactly like this. And so this is a very unusual situation that normally physics has been, there have been these weird experimental results which nobody can explain. And so everybody, and partly because of this, I think physics always had this kind of sociology of, it's very different than math. In math, there's kind of an idea that people should kind of spread out and you should become expert on something and everybody should kind of do their own thing. And in physics, it's much more had always a sociology of that, this new accelerator was built, they turned it on, it found these totally unexpected things. What's that about? How do we explain this? And what does this mean?
Yeah.
And everybody works on the same thing. So, and everybody jumps in on it and starts working on it. And so the problem was that then you removed, in 1970, you then kind of removed that experimental impetus. Since 1973, there literally has not been an experimental result of that kind at all. So, and the things which seem to be experimental results of that kind actually turn out to be wrong experiments. So but there's still the sociology that you should jump on the new thing and the new idea, and everybody should try and figure out this one thing together. And that's so. When string theory came along, it had been like 10 years of this increasingly frustrating situation of not having no new progress into standard model. Nobody knew how to do better. There was no experimental clues. And then, so then this idea came along, and and it was like, okay, well, this is something new that nobody's really tried before, and also it's very complicated. String theories are very complicated. What you can do with 6 dimensions is very complicated. So there's a huge amount of work to be done. So there's hundreds of obvious research projects of, let's calculate what this 6-dimensional thing does. Let's find some other 6-dimensional things. And you had the great genius of the field telling everybody, this is it, guys, this is it. And so it really was, over the space of a few years from 1980s into the late 80s, it really, anyway, it was kind of a feeding frenzy that everybody was changing what they were doing to try to do this.
Yeah, sorry, I apologize for the interruption, but we keep bringing up Ed Witten and the genius of him. Why do you think he believes in string theory so passionately? If he is such a brilliant mind, then why is he not able to spot out the glaring problems with string theory?
Well, I think you fall in love with ideas. It's kind of I think the best explanation is it's like, why does somebody love a certain other person? I mean, I don't know. People fall in love with things, and you can fall in love with ideas and their possibilities. And he and some other people fell in love with this idea in 1984. And anyway, I'm not sure what else. What else? And
is this a challenge? Sorry, is this a challenge most researchers face? Like, you saw Einstein was so married to his idea that he couldn't figure out how to handle the cosmological constant, right? Which ended up becoming one of his blunders. Do you have this fear for yourself as well, that you get so married or so well in love with an idea that you, in a way, get blinkered and you don't expand your horizons in a way?
Yeah, but I've certainly had throughout my career, I've come up, there are various ideas I gotten interested in, and I was very, this is great, this is wonderful. But I mean, the reason I'm actually very excited about the twisters is the first time that this is normally what happens is you do this and then you work on it for a few months or a year or two, and then you start, and as you work on it, you find out more and more things wrong with it. You find out more and more this doesn't work. Or if you like this, whatever your love interest, you start to realize, find more and more of their flaws, and this doesn't
the imperfections.
and so yeah, and then sooner or later you say, okay, well, that really wasn't such a great idea, so I better try something else. And that just, anyway. So the question is more kind of why that hasn't happened, but with string theory, but with Witten, I think that there is a very interesting analogy to Einstein, actually. So Einstein also, after general relativity, he never really accepted quantum mechanics and quantum field theory and what these really, really powerful ideas about quantum theory and geometry, which ended up creating the standard model, were things which he never was interested in. He didn't really want anything to do with that. He had a different idea, and his idea. He had this idea that I'm just going to, I use geometry in a certain way to get general relativity. There are more things to be done with geometry. I can look at more exotic geometries. I can put in extra dimensions. I can, and those doing that, and doing that is going to give me a unified theory, a theory of everything. So that's what he was doing. And so he actually spent, the last 20 years of his life or so at the Institute, working in love with this idea of generalized geometries are going to give me this theory of everything. And Witten's office is kind of just down the hall from where Einstein was doing this. And so it's not, it's not, there is a precedent of the form.